Our topic is encoder, then octal to binary encoder. First of all, encoder is a digital circuit that performs the inverse operation of a decoder. That is, it converts information into codes. Now, octal to binary encoder, it has 8 inputs and 3 outputs that generate the corresponding binary number. It is assumed that only one input has value of 1 at any given time. Now its truth table is drawn. On the left side we have inputs D0, D1, D2, D3 up to D7, and on the right side we have outputs X, Y, Z. Now in the first row we have D0 is equal to 1 and all other in this row are 0 state. So at the output we will get binary code of 0. In the second row D1 is 1 and all other are 0 state in this row, and the output is 001, which is the binary code of 1. In this way, the last row gives us D7 is equal to 1, and at the output we will get binary code of 7, that is 111. The encoder can be implemented with OR gates whose inputs are determined directly from the truth table. In order to get X, we will see the column of X, and where X is equal to 1, we can note the corresponding input, and in this way all the inputs are noted for which X is equal to 1, and then we add all these inputs and the addition will give us the variable X. Similarly, if we want to find Y, then we can see the column of Y, where the column in the column of Y is equal to 1, the corresponding input is noted, and all these inputs are noted for each Y is equal to 1, and then we can add all these inputs to get Y. Similarly, we can find out the Z. So we have three variables X, Y, Z. X is equal to D4 plus D5 plus D6 plus D7. Y is equal to D2 plus D3 plus D6 plus D7. Z is equal to D1 plus D3 plus D5 plus D7. Now we can use three OR gates, one for X, second for Y, and the third for Z. And output of first OR gate is X, output of second is Y, output of third is Z, and inputs of first OR gate is D4, D5, D6, D7. Inputs of other OR gate are D2, D3, D6, D7, and inputs of the third gate are D1, D3, D5, D7. So in this way we will get the values of X, Y, Z. This encoder has limitation that only one input can be active at given time. If two inputs are active simultaneously, the output produces an undefined combination. For example, if D3 and D6 are 1 simultaneously, the output of encoder will be 1, 1, 1, because x is equal to 1, y is equal to 1 and z is equal to 1. The output 1, 1, 1 does not represent the binary code 3 or binary code 6. To resolve this difficulty, encoder circuit must has a periodic function. So we will give priority to the higher order subscript, so then the encoder will consider only that one which is at the higher subscript value, and the lower subscript one will be ignored. The other ambiguity in the octal to binary encoder is that the output with all zeros input is generated equal to output code 0, but the output code 0 should be only when D0 is equal to 1